So this is chapter 7 on chemical bonding. We're going to run through 7.1 in this video. I'm going to try to make this quick because frankly, I'm doing this after school. You can see the date and time at the bottom of the screen. Um, but the lovely thing about this being a video is that you can pause it, you can rewind, you can listen to it as many times as you need to. You can also take and slow it down. If you go down to the little gear, the settings for the YouTube video, you can change the speed of playback, and that can sometimes give more processing time. Okay. All right. So right off the bat, this is the title page for the chapter. We have a picture of coal, diamond, and graphite. Now, I know you call it lead, but it's really graphite. They used to use lead, a long, long time ago for pencils, for writing. Luckily, they stopped that since lead is kind of toxic. So instead, we use graphite. Now, graphite is carbon, just carbon atoms. A diamond is just carbon atoms. Coal is just carbon atoms. These all three are carbon atoms, but they have different physical properties because the carbon atoms are arranged in a different way. And chemical bonding is just talking about how atoms arrange themselves. Okay? So that brings us here. All right? Now, the first thing I want you to do, I know I've got some writing on the screen. I recorded the video and then I had a technical problem. And so now I have to re-record it. All right. But the first thing you should do when you start a new chapter or a new lesson is look at the lesson objectives and the lesson vocabulary every single time because they tell you what you should be learning. And after you read lesson 7.1, you should be able to tell someone, yourself, your mom, your brother, your sister, your dog, your cat, me, a classmate, you should be able to tell people what the definition of chemical bond is. You should be able to list general properties of chemical bonds. And you should be able to define chemical bond and chemical formula. Okay? So, right off the bat, it starts talking about chemical bonding and what they are. So, you may remember that we said that everything that has mass and volume is matter. Okay? And then matter can either be pure substance or it can be a mixture. And we're not really going to talk about mixtures today. We're going to talk about pure substances. Now, a pure substance is only one thing. That's what makes it pure. Okay? So if that pure substance has one kind of atom, only one kind of atom, then it's an element. So elements have one kind of atom. Okay? So we have hydrogen or H2, that's hydrogen, that's gas. Okay, oxygen or O2 is a gas. All right, so these are elements. There are 118 elements that we know of. Now, if there are two or more elements, okay, two or more different elements bonded together with a chemical bond, then that is a compound. So a compound is two or more chemical elements bonded together. An example is water. H2O is water, and at room temperature, it's usually a liquid. Okay. Now there is water vapor in the air, and if in your freezer, there's probably ice. But at room temperature, most water is a liquid. Okay. So if we look at this, hydrogen is a gas at room temperature, and oxygen is a gas at room temperature. But when they combine and form a compound, they form a liquid. So the properties of a compound are different than the properties of the elements that make up the compound. Right? So that is our first big takeaway. Right? So the properties of elements are different than the compounds or the properties of the compounds they make. All right. Important takeaway. Properties of an element are different than the properties of the compounds they make up. Another example, sodium is a silver metal. Okay. Silver in color, it's not actually silver. Chlorine, sorry, the bottom of my board doesn't work great, is a green gas. Okay. Both of those would make you very sick if you try to eat them individually as elements. But when they combine, they make sodium chloride, and that's table salt. That's what we put on French fries. So the properties of a compound are different than the properties of the elements in the compound. All right. So they're talking about that more on this page. Again, you should read the textbook for yourself. Down here, they start talking about chemical formulas. All right, so first, we need to remember that a formula is different than a symbol. A symbol represents an element. So carbon, the symbol is C. The symbol for hydrogen is an H. Okay? A chemical formula represents the compound, the ratio of elements in the compound. Tells you the formula tells you what elements are in the compound, and the formula tells you how many atoms of each element. So, for example, H2O is water. Okay, H2O2 is hydrogen peroxide. Right, and so we know that these are two different compounds because they have different formulas. And since they're different compounds, they have different properties. Right? H2O, we can drink that all day and it's fine. It's good for us. We should probably drink more water than we do. I certainly should. H2O2 is very corrosive in very small percentages. The hydrogen peroxide you buy at the pharmacy is a 3% solution, and you might put it on a cut, and it kills the bacteria cells and stuff in the cell. It also kills some skin cells, so use it in moderation. Okay. In a higher concentration, it can be used to bleach hair. Okay. At even higher concentrations, it can actually, damage your skin and cause chemical burns. It's very corrosive. So water and H2O are very definitely not the same thing. So different formulas, different properties. Okay. So different formulas are different compounds. Another example is CO and CO2. CO is carbon monoxide, okay? And carbon monoxide is it can actually kill you. It replaces oxygen in your bloodstream, and it can make it so that you suffocate even though there's oxygen in the room. And CO2 is carbon dioxide. It actually isn't toxic. It won't hurt you. You breathe it in and out every breath you take. Okay. But carbon monoxide is very dangerous. And if you have any kind of burning in your house, like a fireplace or a gas stove or wood stove or anything like that, you should probably have a carbon monoxide detector in your house. All right. Dot diagram. So all a dot diagram is it shows the valence electrons. So for example, these dots right? These dots around the symbols, those are the valence electrons. Okay? Now, why are valence electrons important? Well, valence electrons are the electrons involved in chemical bonds. They are the reason and the way that elements form chemical bonds. The other thing they're talking about with this chart is how to read the formula. Every formula, every symbol in the formula has a number. So we have HCl. I use a cursive L so that it doesn't look like an I or a 1 or something. All right, there's an invisible 1 right here, and there's an invisible 1 right here. So that tells us that in this formula, HCl, there's one hydrogen, okay, one hydrogen and one chlorine, right? So 1-to-1 ratio. In H2O, there's a 2 here, and that goes for the hydrogen. There's an invisible 1 that goes for the oxygen. So there are 2 hydrogens and 1 oxygen in H2O. Okay. Moving on. Right. Again, here they're talking about water, hydrogen peroxide, carbon dioxide, and carbon monoxide. Right. Down here, there's a bit about chocolate. There's a video you can watch. Might be interesting. Maybe give it a watch. All right. And that brings us to the summary. A chemical bond is a force of attraction between atoms. Okay. It occurs when atoms share or transfer electrons. So if we were summarizing, we might say, all right, bonds, okay, involve attraction and they involve sharing or transferring electrons. I'm going to put E minus as a symbol for electron. All right. So chemical bonds is an attraction between atoms, and it occurs because they shared or transferred electrons. A chemical compound is a new substance. It is not new matter, but it is a new substance, a new arrangement of atoms. So a chemical compound is a new substance that forms when different elements form chemical bonds. A compound always consists of a fixed ratio. And so that's what I'm saying here is H2O is always water. H2O2 is always hydrogen peroxide. Okay? So it's a fixed ratio. It doesn't change. There's only one way to have water. All right. So I hope to see you in 7.2.